Okay. Coming back, I've just shown you how the rate of change or the ratio between the ratio between delta xi and delta s gives us the formula for curvature, and then radius of curvature would be reciprocal of curvature. Okay, yes. Now coming to how do I get the formulae for radius of curvature? Let me discuss about that and then talk about the definition of radius of curvature. Okay. Now, this was the curve I was considering. A, P, Q are the points. Okay. From P and Q, I will just draw perpendiculars onto x-axis. Okay. I will just draw perpendiculars from P and Q to x-axis. And then next what I will do is the distance from P to Q. I mean the tangent P to Q along x-axis would be delta x, and the distance, let this be point be n, and the distance from n to Q along y-axis would be delta y. And then I will, instead of this curve, I will just join P and Q points by a straight line. I think it's visible, right? Now, once I draw a straight line from P to Q, this forms a right-angled triangle, right? Yes. Now, once it forms a right-angled triangle, now using right-angled triangle concept, right? Angle triangle concept, what I can do, the Pythagoras theorem, it's nothing but PQ is my hypotenuse. So hypotenuse square is equal to side square plus side square. Yes, right. Now, what is hypotenuse? PQ is my hypotenuse. So PQ square would be equal to PN square and NQ square. Agreed, right? PN is one side and then NQ is another side, right? So Pn square plus NQ square. Now, what is the distance Pn? Pn is nothing but along x-axis now. So I assume that the little change along x-axis would be delta x. And then along y-axis, it is nothing but my delta y whole square. Okay. On the right hand side, I have PQ square as it is because I'm not aware of what it is going to turn out. Let's divide by delta x whole square and see what happens. Okay. So what I will be getting is PQ squared by delta x whole square. PQ squared by delta x square or PQ by delta x whole square. And then delta x squared by delta x squared gives me 1. And then this gives me delta y by delta x whole square. Yes, right. Now, the same concept again, as P moves from P moves to, as Q moves to P, what happens? The change, whatever is there, as Q moves to P, this way as it starts moving, then what happens, this difference whatever is there, delta x whatever is there, that vanishes off, right? Okay, so I'll just write here as q moves to p, what happens, delta x tends to, that means what I can just write here, q is very close to, the difference between P and Q has become negligible, almost tending to zero. Negligible is denoted by tending to zero. Q is very close to P, goes close to P, actually very close to P. Okay, then what happens? Delta X tends to zero. The difference between P and Q, whatever is there, that vanishes off. Okay. So this equation, whatever is there, I can just write it like this. And then as Q moves to P, PQ value would be what? It would be nothing but delta S, right? PQ tends to almost delta S. Here that point also I will write delta X tends to 0. Also PQ tends to delta S. Okay. You can just see the previous graph to understand. Okay. What that is A to P distance is S. A to Q distance is delta S. So what happens when P shifts to Q, delta is also shifts to P, right? PQ tends to almost tends to delta S. Okay, right. Now what happens? I will rewrite it like this: delta S by delta X whole square. Okay. As PQ tends to P, I can just say limit delta X tending to 0, I can say. And then this is my, of course, one can be exempted because one doesn't have any delta X term. Limit delta X tending to 0. The second term has delta X term. So delta Y by delta X whole square. I'll have something like this. Now, this is nothing but the classical definition of a derivative, right? Classical definition of derivative, right? Yes. So, this would be what? I will call this to be nothing but delta S by, I'm sorry, ds by dx, delta S tends to dx whole square. This is equal to 1 plus dy by dx whole square. Yes. Okay. Now, what would be the value of ds by dx? It is nothing but under root of 1 plus dy by dx whole square. Yes, guys? You understand, right? Now, you can just see here, that ds by dxi or ds by dx is nothing but my curvature. Okay. ds by dx has turned out to be something like this. Yes. Now what I will do is I will write the definition of radius of curvature. Okay. Yes. So what happens here is I'll just write a note, that is the curvature at any point. Okay, this is about a circle. Okay, now I'll just write the reciprocal of the curvature. Okay, the reciprocal of curvature is radius. This is about any circle. When I'm talking about center of curvature, then I'll talk about the circle as well. Okay, the radius of curvature, the reciprocal of curvature is radius of curvature. Reciprocal of curvature. Note, it is not note, this is just definition. Reciprocal of curvature at any point on the curve. Mind you guys, this definition also can be asked in the exam for 2 marks kind. On the curve is defined to be radius of curvature. To be radius of curvature at that point, and is denoted by rho, Okay. Yes. Yeah, with this, I will just stop here, or probably we can just go with finding out solving one more question, but then I will just stop here and do a question in the next session, right?